The journey continues on logarithms. Example 5, part A. We have a function, and it is our job to find the inverse of that function. Now, I would hope that finding the inverse of a function would be a flashback to you, wouldn't it? So let's flash back here. Flashback. Because we found inverses on a previous assignment. So I will bring those notes up again and remind you that we talked about back then, you take it out of functional notation, and I hope you all remember what that means is to replace the f of x, or whatever the function is, with the variable y. So there you have that. All right, this was that Celsius, Fahrenheit, Fahrenheit, Celsius, and other examples like that. Then we talked about if the variables are going to trade places, if the functions go in opposite directions, we switch the x and the y. So I hope you recall that step. Y becomes x, and x becomes y. And again, this should be old stuff, all right? This was assignment 21, as I recall. And then, you might recall, that functions have y by themselves, and so after we make that switch, we don't have y by itself anymore, and so we need to now take this new equation and solve it for y. And the good thing about these, and I'm giving you the easier ones, all right, would be the fact that that y is in one term, so here we are again, we can identify the operation furthest from y in the order of operations and use its inverse. Inverse operations? Inverse functions? Wow! Kind of cool how that overlaps, huh? All right, so in the order of operations, we're looking at y, parentheses, exponents and logarithms, multiply. That add 7 sticks out there. It's the furthest thing down, isn't it? Let's get rid of it. We'll subtract 7. So the logic here is very, 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 very similar to the equations we were just solving a moment ago, depending on when you watched this. The only difference is we're not going to get a numerical value for y. We're going to build a math expression each time we introduce a new step. All right. I hope you would agree at this point that the multiplication by 5 would need to be eliminated. We divide both sides by 5. Make sure you put that all over 5. Let's scroll this up here. Now the equation is x minus 7 all over 5 equals the log of 2y minus 3. By the way, to be more specific, I should have said common logarithm, and that's going to become important now, because I hope you realize at this point, as we move up the ladder here, that we indeed want to get rid of that logarithm by changing this to an exponential. And in order to do that, we need to identify what our base would be for this logarithm. So when it says log, and there's not a base there, what is it? Anybody? It's 10. You're right. You're right, it's 10. You're right. There's a 10 sitting down there. I want to remind you of that. And so again, how do you get rid of a log? You burn it! How do you get rid of a logarithm? Exponential. So that would be 10 raised to this power. 10. I know this looks weird, but put that entire fraction up in the air. Make it a power. It's not next to the 10. If it was on the ground next to the 10, that would be multiplication. This is 10 to that power. And it would equal the 2y minus 3. All right, I will take you back again to when we did examples number 1 and 2 earlier. We practiced extensively with numbers and Greek letters and all kinds of symbols, how to change logarithmic expressions into exponential. And that's exactly what occurred right there. All right, so 10 to that power equals this. And then I think the remaining steps ought to be pretty easy. We need to add the 3 over. That'll leave 2y over here. Now, that's not going to be 13. These aren't like terms. That 10 has stuff attached to it. So basically it's 10, write that up in the air, and put a plus 3 on the back end of it. And then, of course, divide by 2 to finish it off. Boom, boom. All right, so y ends up equaling this expression over here. And then the very last step on a function inverse, you might recall, was to then express it as an inverse function, whereby we said, well, if the y clear back here was f of x, then the y that we got after we switched them would be called f inverse of x. So the nice, beautiful, pretty mathematical answer would be f inverse of x. Let me make that a little easier to read. F inverse of x, put that little -1 power up there, equals, and then we write it down. And again, I would caution you, make sure you put that x minus 7 over 5 up in the air, and make sure it's a base. If it's on the ground next to the 10, that's a different operation. Plus 3 all over 2, and this function would do the reverse process of whatever the original one did. That's an inverse. All right, I think we'll practice a couple more, shall we? Yeah.